Hello, and welcome to the WGG How-To video for designing rockets. In this activity, learners will take on the role of an aerospace engineer. Aerospace engineering involves the design and construction of planes and space shuttles. Specifically, aeronautical engineer covers crafts that stay inside the Earth atmosphere, such as commercial planes, and astronautical engineering covers crafts that leave the Earth's atmosphere, such as space shuttles. Typical duties include directing and coordinating the design, manufacture, and testing of different aircraft or aerospace products, as well as determining if projects will result in safe aircraft and aircraft parts. Aerospace engineers also inspect malfunctioning or damaged parts to determine what the source of the problem is and also generate solutions. Finally, some aerospace engineers evaluate the design of different aircrafts to determine if they meet engineering principles, the requirements of the customer, and of course, environmental challenges. STEM big idea for this activity is chemical reaction. Rockets travel by expelling fuel in one direction, which moves the rocket in the opposite direction. In this activity, learners will simulate this movement by creating pop rockets. By adding an Alka-Seltzer and antacid into water, it produces carbon dioxide. This is similar to the reaction that happens with vinegar and baking soda. When this reaction occurs in a closed container, such as a film canister, the gas pressure builds up and the lid pops off. The faster the gas pressure builds up, the shorter amount of time it takes for the lid to pop. In this activity, learners will conduct experiments to figure out which temperature of water yields the fastest reaction time. The materials needed for this activity include Alka-Seltzer, water, film canisters and the lids, photocopied rocket templates that are provided, scissors, tape, and safety glasses. Before the kids walk in, you want to make sure that you familiarize yourself with this design challenge. You also want to make sure that you get all the materials needed for this activity and have them ready to distribute when the learners come in. Please be sure to read the facilitator guide thoroughly, as it contains very important information to help you guide learners through this activity. To introduce this activity and get kids excited, consider leading a discussion. Show them a picture of a rocket taking off and ask them to share what they think is happening in this picture. They can share with their partner, elbow or shoulder buddy, as well as sharing aloud with the entire group. As learners discuss this general question about what's happening in the picture, be sure to pose a few specific questions like, how does that rocket lift off? And why is there so much smoke? These questions provide the opportunity for learners to begin to consider what are some of the STEM big ideas behind rockets. Now, let's take a look at some of the highlights for this activity. As always, when learners log into the WGG learning environment, they will see an overview of all the steps for the activity. The first step provides background for this activity and presents learners with the design challenge. In this activity, learners are challenged to design a rocket that flies as high as possible using the provided materials. There is one criterion for learners to evaluate their rocket against. It is vertical height. How high does the rocket fly? In this activity, learners will begin to develop their knowledge about chemical reactions by conducting a couple of experiments. Wearing their safety glasses, learners will compare what happens when they put in a quarter and a half of an Alka-Seltzer in cold, room temperature, and hot water. For each condition, they will record the time and seconds that it took for the cap to pop off the canister. Learners will record their experimental data in the WGG learning environment. After learners complete the table, have them click on the Display Graph View button to view an automatically generated graph of their data. Learners will use this graph to determine the amount of Alka-Seltzer and the temperature of the water needed for their rocket. Have them record their ideas or these design decisions into the WGG learning environment. Next, learners will build the prototype of their rocket. Begin with the template and have learners cut out each piece. Roll the rectangular piece around the canister. Be sure to add tape at the bottom so that the cylinder doesn't slide up into the paper tube at launch. Also be sure to leave a bit exposed at the top so you can add the nose cone. For the nose cone, you want to cut out a quarter piece, and then you want to fold into a cone and tape the sides, and then place on top of the cylinder. For the fins, you want to fold on the dotted line and then tape to the rocket. Be sure to place evenly so that your rocket is balanced. Now it is time to test and evaluate the design. Again, be sure that everyone is wearing safety glasses. Learners will work together to add their determined amount of Alka-Seltzer to a particular temperature of water. When the rocket launches, they will need to determine how high the rocket flew. Note, measuring the height can be a challenge. One way to measure the height of the rocket is to launch near a wall with height marking. Observers can report the height, or they can record a video and review it to determine the height of the rocket. Whichever method you choose, just be consistent. Please encourage learners to post a video of their rocket launch to the design wall in the WGG learning environment. And finally, have them record their reflections about the final design and possible refinements they might make in the future. Now it's time for a few facilitator tips where the gotchas can get ya. Again, learners and facilitators need to wear safety glasses. Have the kids work in pairs because it takes some coordination for the Alka-Seltzer drop lid on action. Test the rockets outdoors or in a room with ceilings greater than 12 feet. Remind learners that they need to snap the top on the canister for maximum pop. For testing, make sure learners think about the time it takes to load the canister and also how they will measure the height of the rocket. And remember, it's the height, the vertical distance, not the horizontal distance of the rocket that's being measured. After your session, be sure to complete the facilitator survey. And finally, have fun as you engineer a learning environment that works best for your club.